Welcome to Chapter 8, Section 1. Chapter 8 is all on trigonometry, so let's learn all about it. The lesson essential question for 8.1 is, can I identify the trig ratios of a right triangle? So there's this mnemonic here we're going to have to remember. It's SO, CA, TOA. Now, sine is S, opposite hypotenuse. Cosine is C, adjacent hypotenuse. And tangent is O and A. So I have my right triangle here. And this is the hypotenuse, and I'll say it's 5. And this side is 3 and 4. And then if I'm standing here, this is my adjacent side, this is my opposite side. So I would just be taking these numbers. For sine, opposite is 3, hypotenuse is 5. That's a 3 to 5 ratio. Cosine, adjacent is 4, hypotenuse is 5, and that would be a 4/5 ratio. And tangent would be opposite is 3 and adjacent is 4, so a 3/4 ratio. So all these are is just what number side length to measure or to put in your fraction. And then we'll talk about what to do with sine, cosine, and tangent later. So let's try this. If I'm standing at A, what is my adjacent side? There. This is hypotenuse, and opposite is this side. So sine would be opposite over hypotenuse, so 8 over 10. Cosine would be adjacent over hypotenuse, so 6 over 10. And tangent is opposite over adjacent, so 8 over 6. So I want you guys to pause the video and you guys do these three. Welcome back. Now, if you're standing at B, hypotenuse is the same, but opposite is different because we're at different spots of the triangle. So this is no longer adjacent, this is opposite. And this is no longer opposite, this is adjacent. But if I move over here, then those two things would move. So what would you get for sine? Opposite over hypotenuse would be 6 over 10. Cosine adjacent over hypotenuse would be 8 over 10. And for tangent, opposite over adjacent would be 6 over 8. So I can look at these and I can say, oh, well, I've seen these numbers before. The sine and cosine, those are the same for the opposite angles of each triangle. And the sine and, so those are the same. And the tangent of each one is the reciprocal of that number. Now, what if I said, what if you were standing here? What would my trigonometric functions be for that? Well, I can't do this. This is adjacent, and that's hypotenuse. And I already know what this angle is. This is 90. And later on in the chapter, I'm going to show you how I can solve for these unknown angles. So if it's already 90, I'm not really doing much solving. So I cannot do trigonometry with the right angle right here. Okay, which ratio matches this picture? So if I'm standing right here, I have my opposite and adjacent. So I can go back to this and I can say, oh, opposite and adjacent, that's tangent. So I would write tangent. Okay, you try one. Which segment is adjacent to angle M? Pause the video and submit your answer. Welcome back. So if I'm standing at angle M, I have my hypotenuse, which is this side. That's across from the right angle. And then adjacent would be the other side that my angle touches. So MI would be the right answer. Express the tangent of U in simplest fraction, simplest terms. So if I'm standing here, I'm going to have my tangent is opposite over adjacent. So my tangent of U equals 18 over 30. Oh, wait, no. Oh, no. That's not. Uh-oh. That's hypotenuse. So, and that's opposite. And that's adjacent. So I'm going to need to solve for the adjacent side. Let me do that right now. Okay, so I solved using Pythagorean theorem, found that A is 24. So now I can do opposite is 18 over 24. So now I can get back into the simplest terms. So I'm going to take this and I can say, well, what can I divide 18 and 24 by? Well, I'm going to pick 6. That's going to get me 3. And that's going to get me 4. So the simplest term in fraction form is 3 over 4. Okay, we have this diagram. The right triangle, it's been dilated. So smaller triangle, bigger triangle, they're similar. We know that these two sides are parallel. MN and QR are parallel. Which of the following is equivalent to sine of P? So the sine of P is opposite over hypotenuse. So I'm looking at these. So I'm looking at QRQ, QP. Those are these smaller ones. So I'm not looking at the big triangles here. So I'm going to take sine if I'm standing right here, and I always encourage you to put the person there. Sine's opposite and hypotenuse, so opposite hypotenuse, that's going to be RQ over QP, and I can look here and I can see RQ over QP is this one, so I got that answer. Okay, what are the ratios for these sine features? So sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So if I'm standing at A, I'm going to have opposite, hypotenuse, adjacent. So I have 3 over 8, 5. For cosine, I have 4 over h. And tangent, I'm going to have 3 over 4. Okay, you guys pause the video and you guys try B. Okay, welcome back. So I have B, I'm standing here, I'm doing that in purple. My hypotenuse stays the same, but my adjacent and opposite are different. So sine of B is going to be opposite over hypotenuse, so 4 over 5. And I just realized here I wrote h, not 5. Silly. And then cosine would be 3 over 5, and tangent is going to be 4 over 3. So this section is all on placing my person where it needs to be, identifying opposite, adjacent, and hypotenuse, and remembering that I have SOHCAHTOA, and this is what I got to use all chapter 6. So just memorize this and save yourself a lot of trouble. So back to our lesson essential check-in. Can I identify trig ratios on a right triangle? I think you can after watching this video.